Hello, I am Dr. Ömür Tekince. In this video, I will show you how to perform signal processing on a raw earthquake acceleration record in EQMatch. In this example, we will load a raw acceleration record into the software, apply baseline correction and filtering, compare the raw and processed records, review response spectrum and ground motion parameter results, and finally look at the reporting options. By the end of this video, you will see why a raw acceleration record should be checked and processed before being used in engineering analysis, how these operations are performed in EQMatch, and how the results can be evaluated. Earthquake acceleration records often need to be pre-processed before they are used directly in engineering analysis. One of the main reasons is that raw acceleration records may contain small sensor-related offsets, low frequency trends, or numerical shifts that occur during or after recording. These small errors may not be very obvious in the acceleration record itself. However, when the acceleration record is integrated into velocity and displacement, these small errors can grow and lead to unrealistic velocity and displacement drifts. Baseline correction is used to reduce these type of trends and offsets. The objective is to make the velocity and displacement behavior of the record more physically meaningful and more controlled. Filtering is used to reduce unwanted frequency components in the record. For example, very low frequency drift effects or very high frequency noise may negatively affect acceleration records and subsequent engineering analysis. Therefore, baseline correction and filtering are important steps for making raw acceleration records more reliable before response spectrum calculation, scaling, spectral matching, or time history analysis. However, there is an important point here. These operations should not be applied automatically with the same setting for every record. The user should select appropriate correction and filtering parameters by considering the character of the record, its frequency content, the purpose of the project, and the engineering requirements. Now, let's move to the EQMatch interface. First, we go to the record processing section. In the Load Check Record tab, we can load raw acceleration records in AT2, ASC, TXT, or CSV formats. In this example, let's load a raw acceleration record in ASC format. EQMatch can automatically read the unit of the acceleration record inside the file and convert it to G unit. In this example, although the unit of the loaded acceleration record is centimeter per second square, the software automatically converts it to G unit. You can see input unit and internal unit. In the raw data, you can see unit is centimeters per second square. After that, EQMatch can automatically convert to G units. EQMatch can also automatically read and import the time step of AT2 and ASC acceleration records directly from the file. And you can also see the raw data file sampling interval is 0.01 second, and the EQMatch shows dt is 0.01 seconds. After the record is loaded, EQMatch displays basic information about the record. We can see the input unit, the converted internal unit, the number of data points, the time steps, the total duration, and basic values such as PGA, PGV, and PGD. This initial check is important. Before applying any processing operation, we need to make sure that the record has been loaded correctly. The time step has been read correctly and the acceleration unit has been interpreted as expected. After the record is loaded, we review the raw acceleration, velocity, and displacement time history plots. In the raw acceleration plot, we can observe the general character of the earthquake motion. However, looking only at the acceleration plot is not enough. We also need to check the velocity and displacement plots, because baseline problems are often more clearly visible in the velocity and displacement time histories. If there are unrealistic permanent drifts, trends, or large shifts in the velocity or displacement time histories, baseline correction and appropriate filtering may be required for this record. At this stage, our objective is to understand the raw form of the record and to establish a reference condition so that we can compare the changes after processing. In this example, we can see an unrealistic behavior in the displacement time history. In other examples, it may also be observed that the displacement time history does not return close to the zero at the end of the record. If the loaded acceleration record did not require any processing, we could send it directly to the Files tab by clicking to the Send to Files button. However, since this record needs to be processed, we should click to the Send to Signal Processing button and move to the Baseline Correction and Filtering tab. Now we are in the Baseline Correction and Filtering tab. First, we activate the baseline correction operation by checking the box in the baseline correction section. In this example, we can use third order polynomial correction as the correction method. EQMatch provides different baseline correction options and the user can select the appropriate method depending on the needs of the project. Then, in the action selection, we click the Apply Refresh button to apply baseline correction. After baseline correction is applied, EQMatch displays the raw and processed records together on the same screen for comparison. Here we can especially check the processed velocity and processed displacement plots. If baseline correction has been applied properly, we should see that the unrealistic drifts in the velocity and displacement plots have been reduced to some extent. This check should be performed not only by looking at numerical values, but also by reviewing the graphical comparisons. This section shows raw record summary, and you can see PGV and PGD values. And that is processed record summary, and you can show PGV values and PGD values. Now we activate the filtering operation by checking the box in the filtering section. In this example, we will use bandpass filtering. A bandpass filter preserves the signal components within a selected frequency range while reducing the low and high frequency components outside that range. The low frequency side is generally important for reducing long period drift effects. The high frequency side helps reduce measurement noise or very high frequency components that may not be meaningful from an engineering point of view. In this example, after selecting Chebyshev type 2 as the filter type, we apply the operation by clicking the Apply Refresh button. The important point here is that the filtering operation should not be so aggressive that it unnecessarily distorts the records. Therefore, the raw and processed acceleration, velocity, and displacement plots should be evaluated together. Now, we compare the raw and processed records. In the acceleration time history plot, we check whether the general earthquake character of the record has been preserved. It looks quite good and the change is very small. You can see the raw data PGA 0.98 and you can see the process data table PGA 0.95. In the velocity time history plot, we check whether the drifts has been reduced. We can see that the incorrect drift in the negative direction has been corrected. That is good. You can see raw record summary PGV value is 0.85 and processed record summary PGV value is 0.7. In the displacement time history plot, we check whether the unrealistic long period displacement shifts have been removed. We can see that the displacement behavior has returned to a more normal form and the excessively large displacement has been reduced to a reasonable level. This looks quite good. These comparisons show us how the applied processing operation have affected the records. Significant change may occur especially in PGV and PGD values. This is normal because baseline correction and filtering directly affect the velocity and displacement calculations. From an engineering point of view, the important thing is that the processed record appears more physically consistent while still reasonably preserving the main character of the original record. Now we move to the spectrum tab. Here we can calculate the response spectrum for both the raw and processed records. Pseudo acceleration spectrum comparison is important for understanding how the processing steps affect the spectral ordinates. If filtering is applied too aggressively, the spectrum may change more than necessary in some period regions. Therefore, spectrum comparison is one of the important checks that should be performed after signal processing. We can also review the Fourier amplitude spectrum comparison and the power spectral density comparison to examine the frequency domain changes. Next, we move to the ground motion parameters tab. In this section, engineering parameters such as PGA, PGV, PGD, RMS values, Arias intensity, characteristic intensity, Hosner intensity, predominant period, and similar values can be reviewed comparatively for the raw and processed records. This table allows us to evaluate the effect of the signal processing operation not only on the plots, but also on numerical engineering parameters. When we look at another tab, significant duration, we can compare the raw and processed values for uniform duration, bracketed duration, significant duration, and effective duration. Especially in the significant duration section, when Arias intensity and the 595% significant duration are compared for the raw and processed data, we can see that the content of the record has not been significantly distorted after baseline correction and filtering. After completing the signal processing checks, we can send the processed record to the file section. To do this, we go to the baseline correction and filtering tab and use the send processed record to files button. After this operation, the processed record becomes available for later response spectrum, scaling, 3D scaling, or spectral matching workflows. If needed, the user can also export processed records, graph data, and tables by using the Export as button. In this way, the signal processing operation performed in EQMatch becomes directly connected to following engineering analysis workflows. Finally, to generate a report, we move to the Reporting tab. Inside this section, we click the Signal Processing Report tab. EQMatch can generate report outputs for signal processing results. In this report, raw and processed record information, applied baseline correction and filtering settings, time history comparisons, spectrum results, and ground motion parameter values can be included. The user can generate the report in Word, PDF, and TXT formats. In this video, we loaded a raw earthquake acceleration record into EQMatch, applied baseline correction and filtering, compared raw and processed acceleration, velocity, and displacement records, checked response spectrum, Fourier amplitude spectrum, power spectral density, and ground motion parameter results, and reviewed the reporting options. In summary, the signal processing steps helps prepare earthquake acceleration record for engineering analysis in a more reliable way. To try EQMatch or review the available license options, please visit our website EQMatchsoftware.com. Thank you for watching.